Myself, Rajendra Skarale. My qualification is MSc Chemistry, BM, and experience is of 28 years. Now, today we are going to discuss about periodic trends in chemical properties. The periodic trends in chemical properties the periodic trends in chemical properties play central role in the study of elements and their compounds. That means here as well as governed to large extent the chemical behavior now here the chemical properties are diagonal relationship inert pair effect then next effect of lanthanoid contraction and valency and anomalous properties. Anomalous properties etc. Now listen here. The periodic trends in chemical properties plays central role in the study of elements and their compounds, as well as given to large extent the chemical behavior. The chemical properties are diagonal relationship, inert pair effect, effect of lanthanoid contraction, valency, and anomalous properties. Now here write down first periodic trends in valency, which is also called as valence or oxidation state, Now we are at the first valency or valence. Now first we'll discuss about what is the definition of valency or valence. The number of hydrogen atoms or number of any other univalent atoms which can combine with an atom of any given element, or now we are combining capacity of atom of an element. Now we are the electrons present in the outermost shell are called as valence electron. These valence electrons determine the valency of an atom. That means here for representative element that is S and P block element, here valency equal to number of valence electrons or 8 minus number of valence electrons. Now here, but the transition element exhibit the variable valency. Transition element means here you can consider D block element, D and F block element. D block elements are called as transition element, and F block elements are also called as inner transition element because F block elements are present inside the D block element. Now here write down variation of valency, which is also called as valence in the modern periodic table. Now here write down number 8. Variation of valency in a period, that means here valency increases with increasing atomic number from left to right in a period. This is because here atomic number increases progressively by 1 unit from left to right in a period. Now here number of valence electron increases from 1 to 8 from left to right in a period. Now here the valency of element with respect to hydrogen and chlorine increases from 1 to 4 and decreases from 3 to 0 from left to right in a period. That means here, then write down second. Variation of valency in a group. Now here valency remains same. From valency remains the same from top to bottom in a group. This is because atomic number increases from top to bottom in a group. But the addition of electrons takes place in the different principal cells. That is, here write down outermost cells, that is with increase in the principal quantum level, from top to bottom in a group. That means here the number of valence electron remains the same from top to bottom in a group. Now here write down table valency of representative elements of second period. That means here write down group element electronic configuration then number of electrons in the valence shell, and here write down valency. Now here 1, 2, 13, 14, 15, 16, 17 and 18. Here write down lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Then here write down EC 1s2 2s1, underline this 1s2 2s2 1s2 2s2 2p1 1s2 2s2 2p2 1s2 2s2 2p3 1s2 2s2 2p4 1s2 2s2 2p5 and 1s2 2s2 2p6. Now then write down number of valence electron. Here 1 2 1 2 3 4 5 6, 7, 8. Valency 1, 2, 3, 4. Now here 8 minus 5 means 3, and here write down 5. 8 minus 6 means 2, comma 6, and 8 minus 7 means 1, comma 7, and here 8 minus 8, 0. Second table. Variation of valency of elements of second period. That means here group second period hydride valency with respect to hydrogen chloride valency with respect to chlorine. Now here write down one, 2, 13, 14, 15, 16, 17. That is lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. That means here LiH, BH2, BH3, CH4, NH3, H2O, and here EDUCHEM. Here I do LiH 1 hydrogen, that is valency with respect to H is 1, BeH2, that means there are 2 hydrogen atoms attached to the beryllium, so valency is 2. Here 3 hydrogen atoms are attached to the boron, so valency of boron is 3. Here 4, 3, 2, and here 1. Then write down valency with respect to, here write down first chloride, LiCl, BeCl2, BCl3, CCl4, NCl3, Cl2O, and here Cl here. Now here only one chlorine atom is attached to the lithium, so valency of chlorine is monovalent. Keep in mind here. Here only one chlorine atom is attached to the lithium, and here chlorine is monovalent, so valency of lithium is equal to number of chlorine atoms, that means here 1. Here 2 chlorine atoms are attached to the beryllium, hence valency is 2. Here 3 chlorine atoms are attached to the boron, valency of boron is 3. Here 4, 3, 2, 1. Third table, variation of valency of elements of third period. That means here group third period hydride valency with respect to hydrogen. Here first, second, 13, 14, 15, 16, 17 element sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. Here write down their hydrides: NaH, MgH2, Al, H3, Si, H4, PH3, H2S, and here HCl. Now we have only one hydrogen atom is attached to the sodium, and hydrogen atom is monovalent. So valency of sodium is equal to here number of hydrogen atom. Here hydrogen is 1, so valency of sodium is also 1. Here there are 2 hydrogen atoms are attached to the magnesium. Hydrogen is monovalent. That means here valency of magnesium is equal to number of hydrogen atoms. So here write down 2. Here 3, 4, 3, 2 and 1. Now here write down next term, oxidation state. Now what is the definition of oxidation state? Sign and the charge. Sign and the charge carried by atom of an element in its chemical compound or apparent charge present on an atom of an element in its chemical compound. Now here it may be positive, negative, and even zero in some elements. That means here nowadays term nowadays the term oxidation state is preferred and frequently used for valency. Now here let us consider the example one. OF2 oxygen dichloride. Now here the electronic configuration of oxygen is 1s2, 2s2, 2p4. That means in bracket write down 2px2, 2py1 and 2pz1. That means here oxygen atom have 6 electrons in its valence shell and 2 electrons are required to complete the octet. That means here oxygen atom hence oxygen atom here is 2 valence electrons with 2 valence electrons of two fluorine atoms that means here in OF2 molecule that means here hence the oxidation state of oxygen is +2. Now the electronic configuration of fluorine is 1s2, 2s2, 2p5. That means apply here Hund's rule of maximum multiplicity, that is 2px2, 2py2 and 2pz1. That means here there are 7 electrons in the valence shell of fluorine atom and only 1 electron is required to complete their octet. Hence here each fluorine atom share its 1 valence electron with 2 valence electrons of one oxygen atom in OF2 molecule. Hence the oxidation state of fluorine is -1. This is because fluorine is the most electronegative element in the modern periodic table. Now here write down next example. Na2O, that is sodium oxide. Now here the electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. That means sodium atom have only one electron in its valence shell. Hence, each sodium atom loses its one valence electron to oxygen atom in Na2O molecule. That means here, hence the oxidation state of sodium is +1. Now here the electronic configuration of oxygen is 1s2, 2s2, 2p4. Again apply a Hund's law, maximum multiplicity, that is 2px2, 2py1 and 2pz1. That means here there are 6 electrons in the valence shell, so 2 electrons are required to complete the octet. Hence each oxygen atom gain 2 valence electrons from 2 sodium atom in Na2O molecule. That means here, hence the oxidation state of oxygen is -2. Now keep in mind here, D block element which is also called as transition elements and F block element which is also called as inner transition element. That is lanthanoids and actinoids exhibit variable valency or oxidation states. Now, here write down question. Variation of valency, variation of valency from left to right in a period takes place from number A 1 to 8, number B 1 to 4, number C 1 to 4 and 3 to 0, and number D remains the same. Here the answer is 1 to 4 and 3 to 0. That means C. Question second. Variation of valency from top to bottom in a group takes place from number A 1 to 8, number B 1 to 4, number C 1 to 4 and 3 to 0, and number D remains the same. Here correct answer is D. Which of the following show variable valency or oxidation states. Here write down number A, representative element B. Representative element means S and P block element. B. Transition elements. Transition elements mean D block element. C. Inner transition element. That means F block elements. And D. Both B and C. Here correct answer is both B and C. Now this is regarding about periodic trends in chemical properties. In this case, first we will discuss about the periodic trends in valency or oxidation state. That is, first is valency, which is also called as valence, and second is the oxidation state. Remaining part of this unit will be discussed in the next lecture.